Hi guys, welcome to today's lesson. So today we're going to be looking at some Euclidean geometry, right? I know this is one of those topics that really gives you quite a little bit of a challenge, but we're just gonna look at it, and then I know that because you are watching these shows and you are enjoying them, you're actually gonna learn something, and it's gonna be a bit easier for you to then do them going forward. So specifically under Euclidean geometry, we're going to look at some similarity, right? And we're going to look at some calculations that have to do with similarity. What does it mean when you say two things are similar? The word similar itself, when you look at it from an English perspective, one will think, no, they must just look alike and all of that, but that's not really the case. Mathematically, it means something very different, but we'll look at that as we go on. For now, let's just look at the map of this lesson and see what is it that we need to look at by the end of this lesson. So, I'm going to look at some proportionality, similarity, and equiangular. So, when two triangles or two shapes are proportional, we claim that they are similar. And if they are similar, it then means that they are equiangular, right? We then gonna also look at some some midpoint theorem, and some Pythagoras theorem as well. In terms of riders, the types of questions that you will get under similarity are in two categories. One is when you need to show that the triangles are similar, given that the sides are in proportion, or the other category will be to find the length of sides of similar triangles. And then these are just the two categories that we can then categorize the types of questions that we are going to get under similarity. Our leading question for this lesson will then be, how can you then use Euclidean geometry to solve practical problems? I give you a shape that has a circle, it has a triangle, it has a square. How can you then use Euclidean geometry to try and solve that particular question? That's our leading question. Now, the key words for this lesson as well will be proportion and ratio. So let me just give you a quick explanation of what a proportion means. Proportion means that, let's consider maybe I have square A, B, C, D, right? And also another square here, which is, just assume that it's a square, although it's not drawn to scale, E, F, G, H, right? Both of them are squares. I just didn't draw them to scale. Now, if the length of this square is 2 and the length of this square is 8, 8, 8, 8. So it means that for me to move from one side of the smaller square to the other side of the bigger square, it will then be me multiplying by 4. If I say these two shapes are in proportion, it means that even to move from one other side to the other side, it must be the same as moving from the other side, which is the third side, to the third side, from the fourth side to the fourth side. But if I move from the first and the second to the first and the second of the other, I multiply by a certain number. But from the third and the fourth side, I multiply, and the number is not the same that I'm multiplying by. Then you're not talking about things being in proportion. So I hope you understand what I mean. And we then compare this using the concept of a ratio. Similar triangles, guys, one thing for sure that you need to know is when we talk about similar triangles, size is of very least importance here. It is really not something that you need to even concern yourself about. So these things will be different in size. One can be very big, one can be very small, it doesn't matter. As long as the three angles in those two shapes are equal to each other, right? The corresponding angles. So as you can see, the angle at that on my left hand side will be the same angle as that on the left hand side with those colors, and the red angle with the red angle, and the blue with the blue, right? And then I will show you this when it comes to some questions that we're also going to look at. Also, similar triangles are named in order of the corresponding sides, right? We name these in the order of the corresponding sides. So for example, the side AB must correspond with the side XY. So side AB will be that one, which must correspond to the side XY. And also the side BC must correspond to the side XZ, which will then be the XZ there and the BC, and then the last side will be AC, which must correspond with the side XZ. Now, I know that this is really something that you are used to, because when you talk about ratios, you will see that we'll be using the corresponding sides in terms of those ratios. And it's important for you to know them the way I've just tried to show you in terms of ABC and XYZ. Now, similar triangles, this is the ratio that I'm talking about now. The ratio of the three corresponding sides will always be the same. So, AB and XY, meaning across, right? So it will be this AB here and that XY. Remember I said they are corresponding. BC and YZ, remember we said they are also corresponding. And CA and ZX, they are also corresponding. Now guys, with these things that we've just spoken about so far, proportionality, right? Two triangles to be similar to each other. One, we said that the angles must be equiangular, right? The size of the sides and the shapes do not matter. What matters is if those sides are in proportion based on us using ratio, then we can claim that they are similar to each. They don't necessarily need to be the same thing. No, as long as it's the same category of shapes, triangle and a triangle, because you can't compare a triangle and a square and then say you want to talk about similarity there. That will not make sense. So that's what you need to please understand with that. Now we have a theorem which is called the convex equiangular theorem, which states that if corresponding sides of two triangles are proportional, then the triangles are equiangular. What does that mean? It means that if the two triangles that we have corresponding sides, meaning the sides are in proportion, one, for you to move from one side to the other side, you're multiplying by the same factor throughout, then the angles in those two triangles will also be equal to each other using the correspondence in terms of the triangles when you label them. And consequently, we then say that those two triangles are similar to each other. Why? Because the corresponding sides are proportional, which makes the angles to be equal, and then we then claim that they are similar to each other. And normally our reason is sides of triangles in proportion. Now let's try and apply this just so that we can see exactly what we're talking about, right? If I compare the side AC, or BC rather, and the side AC, it must also give me the same ratio if I compare the longest side, which is 8, and that's XY for the smaller triangle, and the shortest side, which will be the 5 there, which is YZ for the other triangle. Now, the question is, determine if these two triangles are similar. How do you do that? By doing those comparisons that I just showed you now. If I find that my ratio of AB with BC is the same as my YZ all over YX, right? Then I can claim that these two triangles are similar to each other. If that is not the case, then I'm not doing the right thing there. So let me just try and see whether this will definitely work. So this will be 20 over 32, and it must be equals to the YZ over YX, right? So firstly, let's simplify this. The highest common factor of these two numbers will be 4, which will then give me 5 over 8, right? And then let's look at yz over yx. This is equals to 5 over 8. So you can see that these two are equal to each other. So our required to prove is actually proven, because remember I said if we want to prove that they are similar, then this ratio must be true. So you can already see that the ratio is true, that is here. So I know that I already started with making them to be equal before actually solving them, but this is not really the order of you working this out. So when I ask you to prove that the two triangles are similar to each other, you don't start by already saying that their ratios are equal. No. You find the ratio in one triangle, you find the ratio in one other triangle, and then if those two ratios are equal, then you can claim that they are similar, right? Hence, I said the one at the top there is actually my required to prove. That's what they want you to prove, that the ratios are the same. But you don't start immediately by making them the same, because then that's something else. You are now making it seem like you do know that they are similar to each other. So that's one of the examples that you can look at, please. Now, let's look at another, it's the same equation, right? I only used two ratios here. We need to also look at other ratios. So the other ratio will then be, if I look at AC, right? That's the middle side in terms of the length, and I want to compare it with the BC, right? This will be equals to AC is 24 over 32, right? And then the answer that I'm going to get here, which is the ratio, will then be if I divide both these by 4, because that's my highest common factor, it will be 6 over 8, right? And then we go to the smaller triangle. AC is the side that is between the smallest and the biggest side. So the side that is between those two, according to the smaller triangle, will be XZ over, and the one BC is the longest side, which is XY. So XY. And then you look at what is the ratio there. That is 6 over 8. Do you see? Already they are equal to each other. So you can see that if I use the last ratio as well, it will still be the very same thing. But for argument's sake, let's do it as well, so that I show you exactly what I mean. Now I've compared XZ and I've compared it with the XY there, right? Now I want to compare the YZ with the XZ, because I haven't compared that. And if I do that, it's the smallest side and the following one in terms of ascending order. So that will be YZ, which is over XZ, and this will be 5 over 6. This must be the same as, what is the smallest side on the bigger triangle? It will be the AB. So that must be the same as AB over, and then the following one is AC, right? Or CA. AC, which is equals to, so the AB side there is 20 over, my CA is 24. And then if you find what is the highest common factor between the two, it will be 4, which will end up being 5 over 6. Then you can see that it is also the same as that. So you can see that the ratios throughout are giving us the very same value as you are comparing them across board. And then that will make them to be similar to each other. Now also, here they want us to determine the length of XZ, right? Firstly, we need to show that these two triangles are similar to each other. They did not make the statement that they are similar. If they did, then you'd go straight to the ratio. But first, we need to show that they are similar or not. And what I will do is compare this 15 here, which is my PQ, with the QR there. And after comparing that, I must also compare the XY and the YZ there. If they are equal, then it means they are similar, right? So that is 15 over 30, which is the same as 1 over 2. So you can see that, right? And then I said also 9 over 18, which is also 1 over 2. So what? So what is the conclusion? They are similar to each other. Then I can just go to the ratio. Since they are similar, it means the ratio of xz over my yx must be the same as, so remember it's the one at the bottom there, it must be PR. So PR over, I also chose the 15, which was the one PQ, right? So that is PQ. And then you can find XZ using that. So I don't know what this is. I will let it to be X, and this will be 9, and this is equals to 20 over, my PQ is 15. And this becomes 15x equals to, and then this will be 9 multiplied by 20. Then lastly, my x will be equals to 9 multiplied by 20 divided by 15. Then you can just press your calculator. It will then give you your length. All right. So guys, that's what you then need to know about this. You need to be told that they are similar. Then you can go straight to the ratio. If you are not told, quickly with 2 steps, show that they are similar and then use the ratio if they are similar. I hope that is a bit clear for now and you are still enjoying this. Just take a quick walk and drink some water so that there can be some flow of blood in your body, and then I'll be back just after the quick ad break.